Hello and welcome to the Operating Systems 3133 Logix Pro tutorial. This video tutorial is expected to be a supplement used along with the text version supplied in your lab class and simply provides a visual means of exploring Logix Pro the same way as the text version of the document. So we're going to start on page 2, and the first thing we need to do is launch Logix Pro. So if I go into the Start menu, into All Programs, and we're looking for the Learning Pit here, over to Logix Pro, and we'll simply raise up and click on the icon for Logix Pro. So the software opens and we get a couple screens here. The first of all, the one on the left here, on the left side of the screen, is the simulation screen, and the one on the right is the actual ladder screen. So the logic itself is built in this pane or the window on the right side. If we first of all come up to the simulations menu, we want to open up the I/O simulator, the input and output simulator. And now that our simulator has opened, we see the I/O simulator in the left-hand pane, and I'm simply going to drag the divider bar so we no longer overlap our output card located in slot 4, and we'll talk a little more about that later. So what we have here is a combination of, first of all, inputs and outputs, as the acronym I/O stands for. The inputs themselves, we have multiple switches possible that we are tied into our PLC simulator here, and we have multiple outputs possible as well. And if I move my mouse over top of the input switches, I can actually configure or change the type of switch that's wired into each input. So for example, as it says, right click to toggle switch type. If I hit the right click or hit a right click on my mouse button, we'll see we've now changed to a normally open push button. We've now changed to a normally closed push button, a limit switch, and finally back to our toggle switch. Now with the left mouse button, simply by clicking, I can change the status or actually operate the switch itself. So when I activate the switch in this case, you can see that 00 is highlighted red. That means current is flowing through my switch and the status of that input, in this case I:1/0, status of that input is turned on. Simply by left clicking again, I open the switch and you'll see input 0 is turned off. Okay, the next thing we want to do is switch between the I/O simulator in the left-hand pane here and change over to the project tree. So by selecting the red X up in the top corner here, I close the I/O simulator and we bring up the project tree itself. What we want to do is move our mouse over top of I1, which is our input. This is an input data table, and simply by clicking once with my left mouse button, I'm able to open up, again, this input data table. The purpose of a data table is to monitor the status of all inputs and outputs associated with the PLC itself. And an important point to note here is that the PLC itself must be in run mode in order to execute the code and update these data tables. So the only way we'll see a change in these data tables is to actually place the simulator processor in run mode. Okay, so if we look at some of the detail associated with this input data table, at the top here we have the numbers from 0 all the way up, moving left, up to the number 15. Each one of those is a bit. So any input switch is wired into an address, and the bit address is what we're looking at here. On the left-hand side, we'll see we start at 0 and work our way down, all the way down to 7. Each one of these is a word, as further explained in the lecture class. So that means that we have a potential of 8 words multiplied by 16 bits per word for a total of 128 possible inputs on this particular simulator. Obviously that's quite a bit of switches, and we could do quite a bit of code writing with that. Okay, so now that we've taken a look at this input data table, we're going to go ahead and close it. And the next step we want to do is actually switch over to our PLC control panel simply by selecting the arrow at the right hand top of the instruction palette. So we'll go ahead and do that. So now we change back over, and you'll see here we've got a couple of buttons associated with the processor itself. Here's our run mode, our step mode, and our program mode. For the majority of the simulator, we're going to be using either program mode or run mode. And again, in order to execute logic, the processor must be put into run mode. So in order to execute logic, the processor must first of all have something loaded into it. To be able to download our code that's been programmed on the right-hand pane here, we need to hit the download button. So we'll go ahead and do that with our left click. And now we want to execute the code in the right-hand pane by selecting the radio button beside the run statement. So we'll go ahead and do that. And at this point in time, we actually see the scans changing here, our number of scans. What that means is we're executing the code that's been written in the second pane here, and there's not much there to begin with, but we'll add to that in the coming pages of the lab itself. Now that we have the processor in run mode, executing logic, we want to monitor the actual switches tied into the PLC. And we're going to do that by monitoring the input data table. So the next step that we want to do is close our I/O simulator, or look behind it. We want to view our project tree again. So we'll go ahead and close that. And we want to open up the input data table. So with this data table, we actually want to monitor the status of the switches connected to the PLC itself. So with the input data table open, we're going to click on our X here in our project tree to close it, go back to our I/O simulator, and next we need to drag the input data table to the right so we can view it. And we're now going to operate each one of the switches tied into the PLC and monitor the status of those inputs on the data table itself. If I have a normally open toggle switch wired into input 0, for example, right now it's a normally open switch, so current does not flow through it. If I use my left mouse button and close the switch, we'll see that first of all we've illuminated the input 0, indicating that current is flowing through and that input is energized. And if we come back over to the data table itself, let's take a look here. If I highlight my address I:1/0, you'll see the status has now changed to a 1 indicating that that input is on. So again, the input data table, because the processor is in run mode. So the next step is adding a rung branch to the code. If I go up and click on the icon second from the left in the instruction tablet, and I'm going to drag that into one of the green squares here, in this case the one in between the two contacts on rung 0, and release my left mouse button. I've now added a parallel branch to my rung 0, but it doesn't mean much yet because I haven't put a contact in between the two branches. So what I need to do is click on switch 1 and drag it into or in between the two vertical sides of the branch itself, like so. And if I look on page 8, I also need to add a normally open contact with the address O:2/0. Now there's two ways I can add this address. I can either type it in by double clicking here over the question mark, or I can actually drag the address from the light and drop it right in on the contact, which saves you a little bit of time. Okay, so using the same steps, we need to add some more code. If I look at rung 1, I also need to add in a branch. And we're using the same drag and drop technique as we did before. And we'll highlight the bottom left corner here, add a couple of contacts, a normally open and a normally closed. And we need O:2/1 for the first normally open contact. So we'll grab that and drop that in. And we need O:2/2, and let's go ahead and type this one in. There we are. Finally, if we look at rung 2, we need to put in a parallel branch here around switch 1. And it's a normally open contact with the address for output 2. And there we are, we're all set. So now with all of our code entered into the ladder logic pane itself, we need to switch back from the instruction palette into the PLC control toolbar. We're in program mode, so we can go ahead and download and put the processor into run mode. With our program in run mode, we're executing the logic here. We'll go ahead and close switch 0, and we energize or turn on our red light. And if we look at rung 1, we need to, based on our skills and we follow the ladder logic here, O:2/0 is now true, or it's on because we're highlighted yellow. If we move to the next contact in series here, I:1/2 needs to be energized in order to turn on our yellow light. So we'll go ahead and do that. Close the switch, sure enough, our yellow light turns on, and I'll let you continue with rung 2 to energize the green light. And as a final step, we'll go ahead and open up all of our switches here turn off the lights, and move on to the next step. Okay, so moving on to page 9 of the tutorial itself, we can also add documentation rung comments to the code itself. If we return to the instruction palette, we now want to highlight rung 0 with our left mouse button, and then we're going to right click, or you can simply right click straight away if you hover over rung 0 there. We're going to go or select edit rung comment. Now from here, we need to replace the information that's given to us on page 9 with your own personal information, of course. So in this case, we'll enter in our name, the course itself, and complete with the remainder of the information required. And of course, you can use the keyboard to type back over any mistakes you make. And finally, you need to add in your lab class, day, and time. And we'll put a little capital on the D here. Perfect. Okay, so we can go ahead and add the comments that are listed on page 9 to rungs 1 and 2, and we'll go ahead and complete that now. So you'll notice now that we've added the comments to rungs 1 and 2, the rung comment serves as an indicator to the operator, in this case the programmer, what exactly is happening on each rung, to give it further description, to give it some meaning, so when you troubleshoot or come back to these rungs, you can quickly identify with what each rung is doing and continue on to the next step. Alright, for the final point in the tutorial here on the bottom of page 9, we need to print the ladder logic, and that's pretty straightforward. If we go up to the File menu, click File and Print, and of course it's going to ask us what printer we want to print to, and in this case you'd be selecting the printer in IMC, or if you're at home, obviously print your home printer, hit Print, and you're all set. This completes the Logix Pro tutorial for today, and I look forward to seeing you again on tutorials in the future. Take care.